Hey guys, okay, so I've just got in from doing a bit of Christmas shopping. It's quite late, it's 10 to 10. But I will get inside and I will do some explaining of integration. I hope it all makes sense. By the way, hope you're all enjoying the Justin Bieber Usher collab. 'Tis the season to believe. I know you'd like that. Okay, so integration then. When we integrate an expression, what we're actually doing is the opposite to differentiation. We're essentially finding out what the expression was before it was differentiated. So we use the indices and work backwards to find out what the indice would have been before it was differentiated, divide it by the coefficient of x, and then put the indice back on. Okay, so why do we integrate? Well, we integrate to essentially do the same thing as what you've all done before with the trapezium rule. So to find the area under a curve. So on a velocity time graph, to find the distance travelled, we'd calculate the area under the curve, and this is the same thing. We do it here, but as you know, the questions in the higher tier paper would always say estimate the distance travelled, or give an estimate for the area under the curve, or under the graph, and they were sort of usually a straight line graphs, for the speed, distance, time graph. So, you know, this is, you can see here the curves. We could do it. We could make them into blocks. You could even make them into trapeziums, but you're not going to get as accurate of an answer. So the way we do get an accurate answer is by integrating. So essentially we get given the expression, and if we integrate that expression, it gives us the area under the curve. And you can see here it says, obviously you can split the graph up into smaller and smaller pieces each time until they get thinner and thinner and thinner, until they approach 0 in width. So that's why we use the letters dx, but they're not really relevant as long as you know that we integrate to find the area under a curve, because there's a question at the end of the paper that always asks you to find the area under the curve, and you know how to integrate, you're going to be fine. Okay, so how do we do it? Well, if we imagine this expression here has been differentiated, okay, it has been differentiated. So what would the indice have been here before it was differentiated? Well, it would have been x to the power of 6, because we only take 1 off, okay? When we took the 1 off, when we took the 6 down, we multiplied it by a number in front of x. So to find out what that number was, we simply divide 24 by 6. That will give us 4. And you can see here now, if you were to differentiate this, 6 times 4 is 24. Take away 1 from the indice and you get 5. And you've got it. Here, what would the indice have been before? It would have been x to the power of 2. So, because there's nothing there, so we know it would have been 2. So we divide 6 by 2, that's 3. And again, we can check 2 times 3 is 6. Get rid of one of the indice, and obviously that gets left there. And the only time we ever get left with a number on its own is when there's only an x on its own after it, and there's no indice. So you know straight away that that's going to be 5x. Now, there is instances, okay, where, for example, if you were asked to differentiate this 2x to the power of 3 plus 6x plus 8, sorry, okay, what you would have done here is dy over dx equals 6x squared plus 6, and then we wouldn't have put anything else. So this will be relevant to this curve or to anything, to this graph. Now, we're never going to know what that number could have been if we're working our way back from integration, but we have to show that we know that it could have been a number. So in the end here, we put plus c. Like y equals mx plus c, we put the plus c. Okay, so the next one, we know that before it was x to the power of 9, it would have been x to the power of 10. We do 70 divided by 10, which is 7, plus, before it was 2, it would have been x to the power of 3. Now, what have I multiplied 3 by to just get me 1? What would I have multiplied 3 by? Well, it's nice and easy. You know that there's a number under there. There's a number in front of there, which is 1. We just don't put it there. So it's got to be, and you know we did 70 divided by 10. Well, 1 divided by 3. So, of course, the number was 1/3. 1/3 x. Because then when you times 3 by a third, you get 3 over 3, which just becomes 1. You take away the indice. Plus 18. Nothing left there. So, plus. Oh, sorry. There'll be an x that'll go. Sorry, not paying any attention then. So 18x, so it's x squared. And what is 18 divided by 2? It's 9. So it's 9x squared plus, we know that there would have been an x after this one, 1x, and then we put plus c. I hope you can see that, sorry. The next one, okay, let's have a go at this one. So we've got, it would have been x to the power of 3. So if we divide 24 by 3, we get 8. Let's just check. 3 times 8 is 24. Take away 1, 2. Plus, if before it would have just been x on its own, it would have been x squared. 14 divided by 2 is 7. Plus, of course, it would be 9x, because that's the only way 9 gets left on its own. And we've just got to put c on the end there. And the last example here, if I was to integrate this, we know that would have been x to the power of 7. Okay. Now, I don't know what 4 divided by 7 is. So the easiest way to do that is just write 4 divided by 7. 4 over 7, x to the power of 7. That is what it was. Okay. Now this was actually x to the power, or 1x to the power of minus 2. So what did I do, okay, or what will I need to do to make it 1 bigger? Well, I need to be making it x to the power of minus 1, because that's 1 bigger, because that's what I want it to be, 1 bigger, because we're going to do the opposite. So now I need to divide 1 by minus 1, and that is minus, okay? So minus x minus 1. You could even put 1 in front of it if you want. You're not going to lose marks for that, but you can put that there. And let's just check. Minus 1 times minus 1 is just 1. And then get rid of another indice is minus 2, which is x, which is, sorry, 1 over x to the power of 2. So you can always check if you've done something right. And then plus 9x and plus c. Hope that makes sense. If this one doesn't make sense, don't worry, we'll practice a few more of those. But that's enough for now. I don't want to bombard you. Okay. just to end the video, hope you like a photo that I've taken. I wonder if any of you can work out where that is. There's no filter or anything on that. I'm quite into my photography, so it's a perfect sunset. The best sunset in North Wales, in my opinion, in this spot. Do you know where it is? Good luck.